Actually, let me just turn off notifications. That's great. Okay. Great. So, hello everybody, and welcome to the Sole Trader Development live stream. We are live now, coming to you from, I was going to say sunny Winchester, UK. It's actually kind of cloudy Winchester, UK today, but it means I can have my blinds open, which is nice. So I'm actually looking out on my garden at the moment. In Winchester, it's about 2 o'clock in the afternoon. It's an hour earlier than it normally is. Sorry about that, the clocks went forward. If you're in the UK, it'll be the same time as you're used to, except it's an hour earlier, if you see what I mean. And if you're in the States or somewhere else, then we are running a bit earlier, which means you're probably up even earlier, unless your clocks also went back. Anyway, this is the Twitch live stream where we code up Sole Trader. What we're doing is we are working on history generation at the moment. I have completely reworked the history generation in the last 2 weeks or so. Spent quite a bit of time on it, and what I'm doing is, firstly, I'm making it faster and more efficient, and I'm also trying to make it more moddable. So if we have a look at the history generation to start with, this is where I've got to. You can create a new history. I can create now 100 characters in a city, and as you can see, well, if it was actually going to work, I think it's going to crash, which is kind of annoying. But when it works, because we're right in the middle of it, it actually generates really fast and quickly, which is great. So what I'm in the process of doing at the moment is when you take a particular job in the world, so when I say when you, I mean when any character that's been created takes a particular job, every year that they have that particular job or particular life stage, something happens to them or something can happen to them. So for example, if you are a mature student, which is a euphemism for you've gone back to school because you don't have enough qualifications, there are two possible things that can happen to you. Basically there's a 10% chance of you taking some sort of test. So every year this is run, and you might be back at school for say 5 years, there's a 10% chance each year that this might fire. This particular test might run. Now, what that means is that if we don't get the 10%, so the 90% of the time this test won't even run at all, but on the 10% of the time that it does, so on average 1 in 2 students over a 5-year period will get this, they then take an attribute test. They take a test against their mind, and this is an easy test. So this should be reasonably easy to pass. Now, what happens if you pass it is, in this case, it doesn't really matter. So if you pass the test, you're fine, nothing will happen, nothing bad will happen. If you fail the mind test, which means you don't have a very good mind, what happens is that you have an injury happening to you. What happens is your mind goes down, which actually makes it harder to fail this test, to pass this test later, and your wisdom also goes down. Wisdom I'm kind of using as it's a little bit like a mental health metric. That's what I'm using it for. So your mind and wisdom go down, and the reason is because you fires an event which basically states that you are fed up because you are the oldest in a much younger group of students. So basically what's happened is that you don't have the intelligence to figure out that this is what's best for you right now, so you end up being fed up with being in a younger class, and therefore you lose mind and you lose wisdom. So let's have a look at another one. So if you are a prisoner, if you're in prison at the moment, unless you're very smart and capable of avoiding trouble, 20% every year, if you pass a hard wisdom test, unfortunately you end up being beaten up by someone, which is kind of annoying, and you don't manage to keep a low profile, and that's what happens there. And again, if you pass a hard mind test, so that means if you're very intelligent, then also what happens is your wisdom goes down because you get depressed. So your mental health state drops if you're in prison. So let's have a look at a positive one. Let's find one like, for example, freelance trading. So 5% chance every year when you're freelance trading of running this test. If you pass a regular charm test, a normal charm test, you get 1 more wealth point, and you basically have an event that fires that says you've made some shrewd dealings and you've made yourself richer. So there's some examples of some different events that happen when you are in particular life stages, and there's a whole bunch of other ones as well that might happen each year. So you can see there's a lot of these, and there's at least 150. Now most of these are commented out. That's because I started adding these and then thought, hang on, this isn't very moddable. This isn't going to lend itself to have other people coming along, screwing around with the game, screwing around with the history, and kind of making their own cool stuff up with it, which is really what I want to enable. So what I've just spent the last few hours doing is setting up a spreadsheet which states basically exactly the same stuff, but in CSV form. So if we find that freelance trader from earlier, so now we have a row on a spreadsheet which basically states that if statement. There's a 5% chance passing a normal charm test, it'll boost your wealth, and it has a particular string that it uses in order to fire this thing. So, so that's basically what I want to do. I want to get this setup, this spreadsheet, into the game, so that instead of running all of these if statements, which is just very onerous, we can actually work on getting this data driven. So I don't have to have like 700 lines of if statements, and also it means that these things are kind of onerous, they're easy, they're error prone. It'd be nice to be able to see them on a spreadsheet. It'd be nice to kind of do even statistical analysis on these 150 and make sure that we've got a kind of balanced set of things that can happen. It's just easier to read, easier to work with, that kind of thing. So we've already done this process already. If I just load an existing one, so for example, organization roles, you can see I've done this for different organization types. So a Senate, for example, has a president and a senator. Let's see, just move that out a bit. Managers, political assistants, and security guards. And so I've already done this process for various organizations. So I already have CSV loading code in the game, and I put that in this morning actually, or yesterday and this morning. So I know what I need to do, I just need to get on and do it. So now I've got that set up. So I've got the apply ongoing live stage events method. This is the method that basically goes through every live stage and runs those tests or not, depending on what happens. So in this case, what I actually want to do is I simply want to go through my some kind of structure that state basically goes through and works out what these things are. So what I want to do is what do I want to call this structure? It feels like it's a ongoing live stage events structure, but it's really a live stage event structure. So let's go with that. So I've got live stage event index. I might just call that index to start with actually, equals 0. Now I don't have any of the code written for this yet, so I'm kind of writing this code in a wishful thinking fashion. That's what I'm working on. So what I'm trying to do, I wrote a blog post about this recently, is I'm trying to see what would happen if I don't actually apply TDD to this particular process. I've been doing TDD for about a decade, and I'm interested to see what happens if I don't actually apply that. And so in order to mitigate some of the design feedback that you don't get from not doing TDD, or to make sure I still get that design feedback, what I'm doing is I'm actually approaching this code from a usage first point of view, which means I haven't written any of this code yet, I'm just pretending that I'm using it. I have some code to read in CSVs, but I don't have any code to get this particular data structure into, or this data format into the game yet. And so that's what we're going to be working on today. Okay, so we've got an history, and what we can say, actually this is probably going to be reference data, because it'll be in the reference data section because it's not specific to this history run, it's true for any particular run of the history generation. And then I'm going to say that this thing is index is less than history ref data. Now what am I calling these? Live stage event count, or I should probably say ongoing live stage event count, and then index plus plus. Right, so now I've got this thing. So basically I'm assuming that this means that I have access to a live stage event, ls event, equals, oh, I'll probably make that longer actually, live stage event equals history ref data ongoing live stage event index. So let's just assume that I've got them in there. Now this live stage event will be a structure that will look very similar to one of, not those ones, one of these rows. So it'll have a live stage, chance of pass and fail, and then do different things based on what's going on. So let's just make that happen. And processing one of these rows is going to be very similar to processing one of these things here. So that should be quite straightforward to follow. Okay, so if human live stage, so this is what we're currently on, equals the live stage event live stage, then we do stuff. Otherwise, we're just not going to do anything. We're not going to have anything happening. Oh, how far am I in the development in the game? It's probably I would still say it's in late alpha. Hi, MikePack99, thanks very much for following. We are in the process of reworking some of the internals. The game's been worked on for quite a while. There's been a Kickstarter that's run. It unfortunately didn't succeed, but I'm still kind of encouraged by the level of feedback that I've got, and I'm looking to do another Kickstarter in the summer. So just to kind of finish off, get some publishing money, get some marketing money, that kind of thing, pay for the final art assets. So that's kind of where we're at. It's kind of fun. There's some videos online that you can look at if you go to the website and of how it's working. So yeah, please do follow it up and see what you think. Okay, so moving on with this. So we're basically saying if we are in the live stage that we are talking about. So maybe we are a freelance mechanic, say, and we only want to look at freelance mechanic rows, which are up here. So we're going to skip most of them, and we're just going to go through the ones that we care about. Now, I suppose I could store these by life stage. That might be sensible. Otherwise, this might be a bit slow, but I can figure that stuff out a little bit later on. Let's just do the simplest, slowest solution for now, and then I can always make it more complex with a hash table or something similar later on. Okay, so if we're in the right life stage, then basically we need to check to see whether or not that random number is valid. So if there is a random number, so we need to basically say if live stage event random, or percentage chance I should say. If there is a percentage chance, if it's 0, we'll just ignore it. But if there's a percentage chance, if a random number based on the random number index, and the percentage chance is the life stage event, or I should say 100, and then is less than life stage event percentage chance, or I should say if it's greater than or equal, so if assuming that we don't have it happening, then we should just continue. Okay, so if there is a percentage chance, that shouldn't be changed, that should be chance. Same there. And we then run a random number test. If that number, I could actually just make sure that's clear. I've done it again. Chance result equals random number. Let's make it really clear to the debugger when we use this. Okay, and then we can simply say if the chance result is greater than the percentage chance, then we want to continue. We don't actually want to run this particular event. So that's the starting point. The second thing is whether or not there might be a test here. Now remember, not every particular event has a test associated with it. There may just be a percentage chance. In this case, if you're a former president, your wealth is just going to go up because people are going to ask you to do speeches, and so you just make money out of that. Whereas other things have tests associated with them. So what we're looking to do is we're looking to basically check if there is a test associated with it. So if life stage event test, let's go for test attribute, and then we want to do one of these tests. Now we have a test somewhere that we already do, so let's just double check where that is. Attribute test, that's what I'm looking for. So this is what we currently do. So we pass our attribute random number index, and then we have a value and we have a difficulty. So the value is the attribute that we are dealing with. Actually, I'm not sure why that's value. It doesn't seem right to me. Let's see. It's a value. Why is it a value? Oh, it's the value of the particular attribute we need. So we do need a value. Now we need to basically get from the human that we're dealing with the attribute that we are interested in, which is the life stage event test attribute. So this is if it's a strength test, we want the value of their strength, and then we check that against the difficulty of the test, there is always a difficulty if there is an attribute. Ooh, there isn't actually. Ooh, yes, that's true. Okay, so we need to do this slightly differently. If there's a test difficulty, then we grab the test attribute and we grab the test difficulty. But now if the result, oops, there's no result, we continue, which means that if we fail that test, then we continue. Now, there's something else here that we need to check for, which is if the live stage event test was a proceed on pass and we failed, then we continue. Else, if it was proceed on failure and we passed, then continue. Okay, so what that basically is saying is we proceed, basically it's down to this pass and fail thing. So if we want to proceed when we pass the test, then to do something, to do the thing that we do, then if we failed, we should not bother continuing. However, if we didn't want to, if we wanted to fail, then we did pass, then we should continue. So that should work fine. I'll test all of this later. So the next thing to do, once we've done that, is there may not be a test difficulty. There's a couple of cases where we just need to see what a status is. Now I'm only using this here, this value simply at least. I don't think I use that anywhere else in all of the different ones. So this is just, if your status is just greater than good, then you might get a scandal. So this is a hippie living in a commune. If you've got a good status, which means your reputation is very high and you're famous, then there's going to be some sort of scandal if you are living in a commune. Now, I could just make this a status test. I could make this if you pass a particular status test, so if you pass a tricky or probably a hard status test, then you take an injury to your status with your scandal. So if your status is high, then you'll get this. This will just happen. But if your status isn't high, then you're not likely to. The problem with this is I don't want there to be any chance of passing if your status isn't a certain amount. So what I probably want to do, and I need to just try this out and just feel how this works, is increase the chances of this happening, make this a very hard test, which means that when if you have a status, let's just have a look at very hard for a minute. Very hard. Let's see what that. Oops. Come on, wake up. Very hard. There we go. Very hard is -3, which means that if you have a status of 1, 2, 3, 4. If you have a status of less 1, 2, 3, 1, 2, 3, so your status will be terrible, which is impossible. There's a 1 in 10 chance if you're on average. If you've got a fair status, it's a 1 in 7. Depends how attribute test works, actually. Let's have a look at that. Attribute test. It's a random number between 1 and 8. So that means that if we have a very hard test and it's 1, 2, 3, 4, 5, 6, 7, 8, we don't really want this to fire at all if your status isn't above this, say good. So 1, 2, 3, 4, 5, 6 would be impossibly, well, -5 would be even more than impossibly hard. I don't mind it firing if your status is fair, but I want it to fire in these cases definitely. So 1, 2, 3, so 1, 2, 3, 4, 5. That would mean it would never fire. So it feels like it's a very frequently occurring impossibly hard test, if that makes sense. Which means that, so let's just do that. So if you've got a very high status, this might well happen. But I think I might up that to 50. So every year in there, or maybe I'll just do it every time. There we go. So every year, definitely you're going to have an impossibly hard test happening, which is going to potentially knock you out if you're not careful. And the idea is that you the idea is that if you are a hippie and you have a high status, you're going to lose your status eventually. But then this test wouldn't fire again because your status is going to go drop by 2, and then the 2 scandals would only if you happen to have a legendary status. So this will, it's likely that this will fire if you have a high status at some point when you're in the commune, which is kind of, well, that's kind of fair enough. You kind of deserve it. Okay, fine. So that's fine. Which that means that we don't need to consider this at all, which means we can get rid of this row, which is actually quite nice. Now, this is a really good example of why it's really important to write the usage code first. Because if I'd written a whole bunch of CSV importing code to get all of this stuff in, then I would have wasted all the effort to get that in, because I've now realized I don't really need it, which is really, really useful. Okay, so now if we have a test difficulty, then we do the test. Now this is the tricky bit. This is the bit where we actually apply the results. Now it very much depends on what sort of result we're applying. So let's just go through each of these columns. Now these are the different things from basically from here onwards are the things that can happen based on this. So we've done all the conditions. So now these are the things that can happen. So the first thing that can happen is that you might get a boost to an attribute, which means one of your things, one of your statistics may go up. So maybe wealth, mind, wisdom, that kind of thing. The second one is whether you might have a boost to a skill, so ship repair, piloting, that kind of thing. Third one, we have 2 options for actually reducing attributes. So for example, if this is a hippie one, if you fail a simple stamina test, then you may lose mind and wisdom, and that's just because you've taken drugs basically, and it's going to screw with your mind. And then there's also the possibility of death, if we have one column in there with a reason, and then also possibility of going to prison for a number of years. So that's also something that you'll need to keep an eye on. So basically what we now need to do is, in the code up these particular events that can happen. So attribute boost first. So if life stage event attribute boost, then that's really easy. I can just do a change attribute for human, and then basically it's the life stage event attribute boost, and we'll just up it by 1. Simple as that. Okay, same with skills. And note these aren't exclusive. You could have potentially skills and attribute go up. I want this to make this as flexible as possible for modders. And the whole point of putting this in CSV is partly because it reduces the code base. I'm going to get rid of all of this kind of crap code in here, but also to make it more easily moddable. Okay, now we have attribute penalties. So if life stage event attribute penalty 1 and 2, yeah, I suppose it doesn't really matter. I could have an array there. It just kind of doesn't seem worth it really. So you drop that one by attribute penalty 1, and it's exactly the same for the attribute penalty 2. Okay, that's easy to do, and then we have the possibility of death. So if, and actually we should probably put send to prison first, and I think I might even do that first, because really death is the last event you kind of want. So if life stage event prison sentence, then what we can do here is send to prison. So it's quite easy to do. We just say life stage event prison sentence, and that deals with all of the kind of stuff about losing status, and if you have too much status, that handles all of the kind of follow-on events from going to prison. You lose your job and all of that stuff. It's not very pleasant for anyone. Okay, so, and then death. So event death. That's just a Boolean. And then basically this is going to come down to death. Now we already have code for this. Now this is the key thing, the string. So life stage event string. And that's basically like a description. So that will kill off the person. Okay, and now the last thing that we want to do, I don't think with a death we actually record the event. But in this case we also want to say result is false. This is important because the result is whether or not we live. So if we don't, the death the death happening here will actually handle the event. But in every other case, we actually want to record an event, and the event we want to record will depend on this event. Skill training will very much depend on what type of event we have, and actually we can set this here. Event type equals event type. Do we have an event type null? We should have. So this then just means event type equals event attribute boost, and this is a skill boost. Now I don't really mind if this gets overwritten. And then we have an event here, which is event. This is just an event injury. This is also an event injury, and this is also send to prison. What does this one do? Prison term. That's right. So prison term. And then basically in here, unless they die, we're going to record an event because the death code handles recording the event for us, which is fine. Oops. Right. So, and now the string that we get in is this string here. Now this is a an ID string. So the idea is that this is just the message that gets displayed in this particular case. So hello, I've seen just a quick message. What is this? This is Soul Trader. We're looking at C, C++. Do you mean, is it what is the game, or what is the language, or what am I doing? If you're more specific, then I will be able to answer. Okay, so live stage event string. Okay, so okay. Right, so that's good. So now we have the event recorded if we don't die. And in some ways, this isn't very symmetric. It would be nice if I just record the event. Yeah, let's do this. Let's record the event anyway. So this means that this is event type equals event def. The live stage event string is the same, which means that we record an event in every case, which is quite nice. So we handle the death, but I don't know if we need the string anymore, which would be nice. Yes, let's see if that is true. Right. What is this game? It's called Soul Trader. It's the website you should be able to see on the Twitch stream, so have a look and let me know what you think. So that means that we've got, yeah, so now we have record event, so that will record event in every case. The reason I like doing that is because that makes this function symmetric. It just means that it's harder to make a mistake in this case, and actually in just the same way I should be able to do that. Now where else am I calling this in the code? Let's have a look. So those don't count, those I don't care about. So here I care about it. So this is now going to need its own. No, I don't need that actually, because this is code that we are removing. All of those we're going to remove as well. This one is different. So this is where we have a string that has a particular thing attached to it. Yes, this is going to be a bit tricky to do. I'm going to have to figure out how I'm going to do history strings, which is kind of annoying. I was kind of hoping not to have to do that yet. What I could do is simply hash this. That's probably what I'm going to do anyway. Let me think. So one thing I haven't considered is how to do natural causes. How to do, sorry, the strings that are attached. At the moment, the way the history strings work is that any of the kind of strings are stored in a simple enum, and then I just have them as a chart array. Now, by pushing this stuff out into a CSV file, I'm going to have to handle this also as a CSV file, which is kind of annoying. I was kind of hoping not to have to do that yet. But I don't really see whether I can avoid it. I'm doing some of the game. Yes, I am doing some of the game. What I'm working on at the moment is I'm trying to take out a whole bunch of code that describes what happens when people take particular jobs in the game. Every year there's some events that run, and I'm taking that from in the code and putting it out onto a spreadsheet, which will then be read in by the game as CSV. Yeah, so what I'm going to have to do is I am going to have to make these strings that go into a translation file. I just want to get that done, I think. That would be a good thing. Okay, so how am I going to handle that? I wasn't expecting to write this code yet. I think I'm going to want to, firstly I'm just going to want to record this event as we were before. All I did was take out, there we go, all I did was take out the event from that death thing, that death call, so now I'm just recording it. Yeah, there we go. Okay, so where were we? So we have got to figure out what to do with those history strings. Anyway, so what we've managed to do is, let's just find that apply ongoing. Yeah, so what we've managed to do is we've managed to take all of this kind of switch statement here, all of the different things that could potentially happen, and we've converted it into a page, quite a simple page of code to just go through and read that CSV, which means that we should be able to now delete all of this. Yeah, pretty much all of this. Yeah, all the way down to here. Fantastic. I don't know how many lines that was. 484. Nice. Now we have a big to-do here, which is I haven't actually converted the strings. Hang on, what's going on here? Which is that? Oh, that's the apply. Why is that? I'm missing something. Let's see what's going on here. Ah, missing semicolon. Sorry, the Vim was syntax highlighting, and I noticed that basically what was happening was that it wasn't doing the brackets correctly. So that's much better. So the ones that I need to put in, though I still need to put in, we don't need that, we don't need that, are these ones here. So I just need to pop that in to do implement ongoing events, or I should say add ongoing events to CSV file for these ones here. Yeah, and this can just be return result. Return result. Okay, cool, brilliant. So now what I need to do is basically check this. If I compile this, what will happen is that it will point out that we've got real problems with the code. So now we don't have this ongoing live stage event count. Right, so the great thing about starting usage first is that what I've done is I've written all of the code with the data structures in it that I want to have, and now I don't have any of those data structures. That means that I can basically just go through and fix the errors, kind of like TDD really. I can fix the errors that I see in front of me, which means I only write the code that I actually need. So in this case, in the reference data, where's the ref data structure? Here it is. I'm going to need a ongoing live stage event count. Okay, I also need an I'm going to need a live stage event array, event index, just one of those really, but I also need it to be max life stage events. Now what is the max of life stage events? Well, I've kind of got 120 at the moment. It probably need to be about 256. I'm not too worried about this. This is reference data. I don't need masses and masses of them, so they're not huge and they aren't massively mobile in memory, so I don't need to worry too much about the size there. 256 will be fine. Okay, once I've got those, I now need to create a life stage event struct. Okay, now the life stage event struct is going to have some stuff in it, which we will look at in a minute. I'm sure the compiler will tell me about the problems. Okay, so undefined method life stage, that's because this thing doesn't have a life stage type of life stage. I'm going to initialize this thing in a minute. It's also going to need a uint32 or probably just a uint8 actually, percentage chance. It's going to need a test difficulty. Now this is a difficulty object. Difficulty is just the enum, which is just hard, easy, that kind of thing. Tricky, simple, very hard. Then we also have an attribute, which is test attribute. So these things here are the conditions for this thing to happen. And then we also need a bool, which is proceed on pass or not. Okay, then we've got an event type of null. Well, let's just compile the code and see what's next. That's the simplest thing to do. Okay, no member named attribute. Attributes. Okay, yes, I did mean attributes. Okay, no member named event type null. That's no good. Oh, it's just event null. Yeah, that should probably be event type null. Do we use event null anywhere else? No, we don't, so I can just rename it. Yeah, I felt like event type was the best thing. Okay, so what's next? Okay, no member named attribute boost. Great, so we're now on to attribute boosts. Where are we? There we go. So this is the attribute to boost. And then we also have skill boost. And then we also need a penalty 1 and 2. Penalty 1, penalty 2. No messaging function call for change attribute. That's right, because it's a change skill. Thank you, compiler, for picking that one up. Okay. Right. Use of undefined identify event skill boost. Interesting. Event skill boost does not exist. This definitely exists. Skill training. Skill training. Okay. What's next? Right, no member name prison sentence. No, there's no member name prison sentence. That's because we don't have one yet. Oh, wrong code. So this will be a uint8 prison sentence. Now if that's 0, then we just assume we don't have one. And no member name death. So this is a bool 32. Death. Does death happen? And then we have no member name string. So this is going to be history string. Now this bothers me. It's an enum at the moment. It's going to have to change to something else because there's no way that I want to have a big array to look these things up in. Because otherwise what's going to have to happen is I'm going to have to basically store a big array of things to look these things up in, and that just doesn't seem sensible. Just because I could do that to start with, no, I think it's a terrible idea. I'm just going to bite the bullet and do the CSV thing, I think. Okay, so this is history string. I'll have to figure out what one of those is in a minute. Okay, that compiled. Okay, so obviously it's not going to work yet because we don't have anything loaded in, but it should actually run. Did I compile that already? Yes, I did. Okay, so it should actually run. So if we switch to Xcode and actually run the game, we should just have no events running because we don't have any of these things initialized. As you can see, the history is running perfectly fine, and people are taking jobs and all of that kind of stuff. So if we view the history, we should be able to see that there are various people here. So for example, a mining engineer trainee took an astromining training placement with the factory and city, no cities in there yet, became a political assistant, and met a guy called Hugh Butler Shoebridge, fun, who's 34, a freelance mechanic. Interesting. He's got loads of friends. He's a very popular guy. Good guy to know if you're playing the game. He's got a memorable name, Hugh Butler Shoebridge. And what does he do? He's a freelance mechanic at the moment. Interesting. But he was a mechanic and then he enlisted for a while. So he became an ensign. But there are no events. You can see that nothing happened to him as a result of that, which is not what we want. So the next stage is to actually load these things in. Now, the way that we do that is currently a bit hokey. It's just not that brilliant. So at the moment what we do is we read a whole asset file, which isn't very good. But it's basically, where are we? Live stage ongoing events. It's not brilliant, but it works. And this is a new state blobs data. I'm going to update this probably with an asset streaming thing of some sort. So all that does is it just dumps the file into a file arena. So it dumps the entire file into memory. That is it. And then once it's done that, then it, that I don't need to look at, then it basically passes it to the new state here. So then what we need to do is basically load strings and tokenize them. Now this is interesting. We have a string store here, the org role store, and then we load strings into it using the file arena. It would be nice to be able to drop that file arena again, if possible, at this point, but we don't do that yet, which is kind of a bit annoying. And we probably also need here a ongoing life event store, string store. And then I also want to just basically create a new one of these, store. And this is going to be the ongoing life event. What did I call that in the application? I mean, in the new state blob data, let's see. Ongoing live stage events. There we go. So that's got the file in, then this load strings from will just load it into there, and then if I just pass it to initialize, this should be okay because we can create as much memory as we like for this file arena, because to be honest it just gets dumped at the end of the load anyway. So we've got initialize history reference data, we're passing in the life event data, so let's make sure that compiles. Use of uninitialized ongoing. Try again. Okay. Ongoing live stage events. Oh yes, I renamed it data. This is now org ongoing live stage events store. Event store. Ongoing life event store. I should really make that a little bit easier to remember, but never mind. It's okay. Right, how are we doing? Right, no matching function for call. Right, so let's just rebuild my tag list and just jump straight to that. Right, so the reason that this is a problem is because we don't have string store. Now this is ongoing string store, and this one is actually the org role store. Is that correct? Did I get that right? Org role store, yes. Okay, so the store is no longer good enough. This needs to be the org role store. Great, and is that it? I think so. Okay, so what happens here is this is where we initialize our history for the first time, or the reference data for our history. So what we do is we basically just grabbing all of the kind of basic, the basic way that the thing is working. So this is exactly where we want to tokenize that CSV string and basically go through and load it. So we want to do something very similar to what we're doing here. So instead of the org role store there, we want the ongoing live event string store. And exactly the same here. Oops, there, no. Don't know what's going on there. Ongoing live event string store. Okay, so what now I've got is basically the first where are we? The first row in this file here has come in to this point here. Now I've just got a bunch of offsets which I then can pass in. And the idea is that I just tokenize that based on commas. So that will hopefully get us to the point where we've got the correct things here. So let's start with a live stage type. Now what we need to do is now we have a set of offsets. The offsets will basically be all of these strings. Now offset's a terrible name, let's rename that. Fields, it's a much better name. Fields. Okay, so each of the fields is now in this array. So the simplest thing for us to do is to simply say something like live stage type, live stage, and let's grab from offset 0 the particular live stage that we are in. So this is this live stage here. Right, now if the live stage is not null, live stage null, null, there we go, then we can actually do something. So this will help handle the header. So if we have a header here, we should be able to, let's just double check, if we have a header here and that we don't find it, then we can just ignore it, and it's the same for this here. We'll just ignore anything that we don't find. Okay, so if the live stage isn't live stage null, then what we need to do is basically go through all of the different things or the different columns that we've got, and we can find that out quite easily from the new live stage event. Yeah, the live stage, no, not that one. I'm just trying to find the live stage event thing that I created. There it is, live stage event. Brilliant. So we've got the live stage, the first one, then we just need the percentage chance. So the first offset is the percentage chance. And actually here we can just create a new one. So we can just put this stuff directly in, because there's no point in doing this. In fact, yeah, this one doesn't really need a new method anymore. Okay, so here all we need to do is we're going to have a new one, so we do live stage event. Event equals, we need to push a struct on the arena that we've got. Yeah, that's fine. This will be the reference data arena, so that's fine. We're going to push a live stage event struct on there. Okay, then what we're going to do is, yeah, that's right. The event percentage chance is just the CSV uint 8 fields 1. I renamed this to fields, didn't I? Great. Now the second one is going to be, it's not the difficulty, is it? What comes next? Let's put these in column order, otherwise it's going to be confusing. Percentage chance, pass fail, attribute difficulty. There we go. Then we got event proceed on pass equals CSV bool 32. Oh no, it's CSV pass or fail. Fields 2. Okay, and then we've got test attribute, test difficulty, which is easy enough to do. Test attribute, attribute. Some of these methods don't actually exist yet, but they will. Okay, so like I said, I must get those right. Writing this usage first. If you spot any typos, please let me know. I'm very happy to receive typo information. It's actually quite hard to talk and type at the same time. Okay, so let's do attribute boost, and then skill boost, and that's not going to be that, that's going to be a skill, and this one is going to be, let's just take this one, penalty 1, penalty 2, and this is going to be 6, 7, 8. And then we've got a uint 8, so let's just grab this one. Prison sentence, uint 8, field 9, and death. Now this is a bool. Bool 32. Okay, now the history string, this is the tricky bit. I don't know what to do about this. I don't know what to do. This is going to be difficult to figure out. I'm tempted to just do something like this. In fact, that may be the right answer. Basically, take a string hash of that particular history string and then use that to basically figure out the index on a big strings hash table. Something like that will probably work. Figure out what to do with strings here. So that's an important one, but I think that's probably the right thing to do. So if I take a hash of that, then we're in good shape. So this stuff is all bogus, don't need any of that. Okay, so then we've got our live stage event. What I need to do now is just do history, ref data, ongoing live stage event, and then I've got history, ref data. In fact, have I just got the ref data? Yes, I have. Don't need the history. Same here. Ongoing live stage event count plus plus equals, I'm going to assert here, but I'll do it in a minute, equals event. And assert ref data ongoing live stage event count is less than max. What was the max I said? Max was something like max live stage events. Pretty sure it was max live stage events. Yes, it was. There. Okay. So now, in theory, that should read everything in for me. Now I thought about using a library for this stuff, for CSVs, and then I thought, you know, reading CSVs is super easy to do. I can just write my own. It isn't going to take me very long. Okay, let's see. Pass or fail. Right, so now we've got some stuff that we actually need to fix in our history stuff. Now, where are our CSV methods at the moment? So value CSV, that's in traits. Yeah, I think this can probably go in traits too. So this is going to be a bool, basically. Bool 32, CSV pass or fail, based on a column. Okay, and we're basically going to say that the bool 32 result equals false. And we're basically going to say if string compare column with pass result equals true. Yep. Now, if that's the case, then in this case assert string compare column fail. So basically either it's going to be pass or it's going to be fail. Whoops. So it sets up a false. So if we pass, then we return the result as true. Otherwise, we just want to make sure that it did actually say fail if it didn't say pass. And we'll assert there because if we assert, that means that we and know that we've got invalid data, and that's quite important. Okay, so that one's done. So the next one is CSV attribute. Now this one's super easy. Just going to grab the value here, and actually value again here should be assert result. We should actually assert that the result is true there. Now what happens in the case that we don't have one? We don't care if it's an empty string, we don't care. So if column, so that's easy to check, if column is the null terminator, which means that if the first, there we go, first entry is null, then we don't bother doing anything. But if it isn't null, we want to make sure that we actually get one of some description, so you can't just put anything in there and for it to work. Okay, now I've done that, I can do exactly the same thing as that for the attribute. Attribute value, so that's attribute. Attribute strings, again, same thing. Attribute strings, and that is attribute index. Great, so what I'm doing is going through a list of strings and basically looking up the value to make sure that I've got the right thing. Okay. Right, so in this case it shouldn't be an attribute, no, value, attribute null, no, that's the one. Can't be a value null, and now undeclared identifier attribute strings, that's correct. We need to do the same thing as we do for the values, which is basically just a very simple list of attribute strings. Now, where are the attributes? Where are they? Here they are. So what I normally do is do this, and then pop those in there, get rid of that one, so that one is just that, and then I just record a little macro. Oops, let's try again. Let's try again. Insert, that's it. Okay, 6, there we go. I probably could have done that quicker without recording a macro, but there we go. Right, so now we have attribute string. So now what it's going to do is just going to look up in that list to make sure that we've got the thing that we want. Okay, difficulties, exactly the same as the others. So let's start with the difficulty strings, because that's easy enough to do. Difficulty strings. Difficulties down here. Let me just pop those here. Now these are slightly different because there's no null difficulty, so we're going to need to treat this slightly differently. Okay, record a macro, so forward space, delete to comma, add insert quote, go down onto the next line. Okay, there we go. Now that is probably worth recording a macro for. Okay, so CSV difficulty. In this case, if we don't have one, the problem that we have is that the difficulty of normal could actually be a valid difficulty. So we might actually need to change our code. So let me explain what's going on. The test difficulty normal will actually return 0 because normal has got the difficulty value of 0. That's not the same as absent. But unfortunately inside my struct I have no concept of difficulty is absent. So but I'm actually using that, which makes it tricky. Because when I go to the ongoing live stages, here we check to see whether test difficulty is there or not. Now in this case, if it's normal, if it's absent, it will still be 0, which means that no normal difficulty tests will actually fire at all, which means that all normal tests will actually pass right now. So I can't check this. I can, however, check test attribute now, because I decided not to have that extra column in there, if you remember from earlier. So yeah, so let's see if I can get this done before the hour is up. Might have to go a little bit over, but it'd be nice to be able to just at least step into this code. Difficulty result. If there is one, oh, I've got that wrong the wrong way around, haven't I? Oh no, I haven't, that's fine. So if there isn't one, I just want to set that to 0. Yep, that's still valid, but the difficulty of normal may well come through, and that's fine. Difficulty strings, back difficulty strings. Oops. Difficulty index. Okay, so that's all the difficulty things, and now I'm not using it for that. So potentially we could get a 0 if there's nothing there, and we just have to deal with that. We could have a difficulty null, which is a different value, but that would have to be a magic value. I hate magic values. I prefer to just assume that it's not there. I don't like setting it to 999 or something. Right, cannot initialize return. Yeah, that's because that's a difficulty. It's coming back. Okay, CSV skill, we've got one more to do, and then I think we're there. So let's replace in here difficulty with skill. Yes, 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 yes. Okay, so that's just the same as the other one. And this skill result is not normal, is it? Its skill result is skill null. Have we got skill null? We should have. Let's see, skill. Computers is null. No, that's not right. Skill null. That should be equals 0, just to make it really clear. Okay. And that's just the same. And now if we go to, oops. If we now go to value strings, find those ones, we should be able to do a skill strings, which will be very easy to do because we just grab that, grab those, and then we're there. Okay, so I think we've hit our time limit. We're just a little after 3. I'm going to continue finishing this though, because I think it would be nice to just get done what we said we were going to do. Let's see, is my macro still going to work? No, it doesn't work. That's annoying. So yeah, I'm very happy to answer questions at this point. I'm just finishing this off. I'm not very far from it. So if you want to ask questions, this is a good time to do it. I'm going to finish this because it's important. Well, is it important? Yes, it is important. It's certainly important to the game. Okay, so history string, right, so this is a problem, yes, because we're basically saying they were hashing this thing into an unsigned int. Now, I haven't rewritten this hash function yet, and I kind of need to because I don't like it, but I think I may just find it quickly. This one here. Yeah, it doesn't use my new types. It's not very nice. I am just going to move it. I am probably just going to just make it move, use the new types. UN32, start. UN32, start. It's not that bad. It's not terrible. It's just, yeah, it's all right. Anyway, so I'll leave that one. So if we're hashing this thing, fields 11, right, user can identify event. What's wrong with that? Ah, yes. We are not in the thing. Now, event string is hash. Now, I think what I might also do is I may well define type def hash. Yeah, I think I'm going to type def uint32 to hash because I want to make sure that my hashes are separate. And I might even just define it as a string hash. That might be quite a good idea. So we can really make sure that these things are distinct. I want to segregate my interfaces. That's like the solid principle I, interface segregation principle. The idea is that you want different objects with different types to do different things. That potentially will help my compiler to find problems for me. So let's find where I'm referring to that, which is in my life stage event. That one there. No, not that one. Oh, there's loads of them. Yeah, this is the old history code that just doesn't work well. I need to go to new history.h. Life stage event, where is it? Here it is. So this is now going to be a string hash to start with. Okay. Right, no matching function call to record event. Why not? Ah, because of the history hash, the hash. Yeah. Okay, so my next to do is definitely going to be to fix history string hashes. Yeah, I think we're done with that. Okay, so I think I'm going to call it a day for today. Thank you very much for coming. Please do follow me on Twitch. I am here every Monday, same time, same place, pretty much. So I run one of these all the time. If you're interested in Sol Trader, please do check it out. You'd be very welcome to stop by at any live stream that you want to come to, ask questions. And yeah, if you have anything to ask, you'll be very welcome to do that. Please do also follow me on Facebook and Twitter if you're interested. The game hopefully will be on Kickstarter in the summer. So if you are interested in seeing this game through, then do please follow me on various social media, whichever takes your fancy, and you will hear about it through that. But yeah, so great to see you all, and hopefully I will hear from you soon. Okay, bye.